Dear my students, in this video I will explain you phenomena of self-induction and coefficient of self-induction. Here in figure 1 we have a conducting loop having many turns, or it may have a single turn also. Turn are shown because we can increase, and or this is in figure 2 it is solenoid which is connected to a battery through rheostat. Both the coils and the solenoid are connected to battery through rheostat. Rheostat is a device which can change the magnitude of current here, no direction. So it has been noticed that, or practically you understand, when current is changed in the loop, the magnetic field inside the passing through the loop will change. Due to that change of magnetic field here or here, there will be change of magnetic flux which will induce an EMF and hence induce current flow in such a manner that according to Lenz's law that opposes the cause by virtue of it is produced. So this whole phenomena is called self-induction. So I am right here, if we pass varying electric current through a coil, figure 1, or through solenoid, figure 2, then a varying magnetic flux is produced. This varying magnetic flux induces an EMF and hence induced current flows through the coil, whose direction is according to Lenz's law. That is, when current passing through the circuit is increasing, then induced current will be in the opposite direction, and vice versa. Means when current passing to decrease by bringing the rheostat this way, then induced current flows in the same direction. This phenomena of inducing is called back EMF. Back EMF in coil or solenoid is called self-induction. Is called self-induction. So what I have written here, so actually we have to explain, that's why the paragraph becomes longer. Okay, when we pass varying current, rheostat can vary the strength of current in the coil or solenoid. Magnetic flux linked with the changes, and that varying magnetic flux induces EMF, due to which current flows such a way that if this current passing through this is increased, then induced current will be in opposite direction, and vice versa. So this phenomenon is called self-induction. Now practically magnetic flux linked with coil is proportional to current. That is phi equal proportional to I. But there generally ion turns. If there are capital N turns, then N phi proportional to I. Here N phi is called magnetic flux linkage, or we can write here N phi equal to Li, where L is constant of proportionality. And is called coefficient of self-induction or inductance of the coil or solenoid. L, coefficient of self-induction or inductance. L, the phenomena of self-induction is one thing, and coefficient of induction other thing. L. Now, what is in fact L? If I is 1 unit of current, then L will be N phi. I explain many times what is L, what is inductance basically. Just if I ask you what is the speed, that is the distance traveled per unit time. Similarly here, what is L? Therefore, coefficient of self-induction or inductance, L also called inductance of coil, is numerically equal to the magnetic flux linkage of coil or solenoid when unit current is being passed, is passing through it. L, coefficient of self-inductance, is numerically equal to the magnetic flux linkage of the solenoid when unit current is passing. Unit, the unit of current may be any, but SI unit is ampere. So that way, what is the unit of the unit of inductance or coefficient of self-induction is Henry, capital H, written as Henry and symbol capital H. So when is 1 Henry? If on passing a current of 1 ampere through a coil or solenoid, a magnetic flux linkage of 1 Weber. Unit of magnetic flux linkage is Weber. Of 1 Weber is induced, then coefficient of self-induction is 1 Henry. Of self-induction is 1 Henry. If on passing current of 1 ampere through the coil or solenoid, a magnetic flux or flux linkage of 1 Weber get linked, then coefficient 1 Henry. Remember, this is very important to define 1 Henry. Generally, people ask. Now, further we know that E equal to minus d upon dt of n phi, but here n phi equal to Li. So you can write, hence E can be minus L. Sorry. Yes. B upon dt of Li. So L तो constant तो proportionality है. It can be taken out minus L di over dt. I just defined self-induction. When varying current is passed, when varying current is passed, so if di over dt is not zero, means it is constant. If current is constant, does not change, then di over dt is zero, so no EMF will be induced. So this equation shows that varying electric current in a coil induces an EMF, and that according to Lenz's law, this induced EMF will oppose the coil by virtue produced. So it is called hence back EMF. अगर ये जो EMF लगाया है उसका पोल पॉजिटिव है तो इंड्यूस EMF नेगेटिव, it will be opposite to that. Lenz जो कहता है ना. Here we can define again L. If di over dt is one unit, means if current is changing at unit rate, then L equal to modulus E. In coefficient of self induction numerically equal to induced EMF. Avadata is equal to magnetic flux linkage. But this will show, and again we can say that and hence L is numerically equal to the magnitude of induced EMF when current in the coil is changing at unit rate. If current is changing at unit rate, then coefficient of self induction numerically equal to induced EMF. Further, unit Henry can be and therefore, and hence, if rate of change of current of 1 ampere per second, 1 ampere per second induces an EMF of 1 volt in a coil or solenoid, then coefficient of self induction or inductance. I am stressing it also called inductance, not induction. Coefficient of self induction or inductance of coil or solenoid will be 1 Henry. We will prove that inductance value of L depend on how does it depend on shape or size in next video. This topic is very important and has a lot of application in our life. If capacitor inductors are not there, then our life will be something very puzzling. And no communication will take place what we are doing here. So I hope you have enjoyed this topic, and please ask your friend to subscribe this channel, and if you like the video, share the videos, and it will help the society, not me. I am a retired teacher here. I have lot of experience of thinking and telling student problem, solving problem. So that will help the society, not me. So please, it will encourage me if many viewers are there. Thank you.